Good morning and welcome to our digital discovery webinar today. My name is Matt Minner with Catalyst Connection, our Director of Technical Services, and we're happy to bring you our digital discovery webinar series through our Digital Bridge program. We'll share a little bit more about that in a moment, but first want to introduce today's guest and our featured third-party provider, Datanomix. We're going to focus around CNC shop monitoring, industry best practices to maximize revenue, profitability, and efficiency. And with us today, we have Brendan Walsh. How are you doing, Brendan?
I'm doing well. Good morning, Matt, and good morning, everyone on the call. Thank you so much for joining. My name is Brendan Walsh here representing Datanomix and excited to talk to you folks this morning.
Well, we're excited to have you. I appreciate you taking the time to be with us this morning, Brendan. And so as we get into things, we'll turn it over to Brendan here momentarily. But just for those of you who may be joining for the first time, there's a little bit of background on our Digital Bridge program that is under the Economic Development Administration, part of their Build Back Better program. And it's a focused program in Southwest Pennsylvania to support regional manufacturing in their efforts to adopt new technologies. And through that, we have a number of partners. Catalyst is the lead organization, but we work with organizations like the Digital Foundry, Manufacturing Futures Institute, which is run by CMU, the University of Pittsburgh, with which we have a really special program focused on supporting manufacturers directly with their graduate students to solve challenges through quick programs. We call the Pennsylvania Robotics and Technology Fellowship. So that's a great opportunity if you've got some back burner projects that you're looking to tackle, definitely reach out to us, and that's a no-cost opportunity for manufacturers and a great way to engage with the future workforce. And along those that I mentioned, the PA Robotics and Technology Fellowship already, but we also have technical assistance available, access to technology, R&D, and demonstration facilities. Our access to capital, and unfortunately at this point we have fully leveraged that to this point, but we are actively working to obtain new funding. So always great to connect with us to see what opportunities there may be for your projects. And the projects that Digital Bridge, that type of funding can go to, it really covers the gamut of technology, be it robotics, the digitization space, additive manufacturing, cybersecurity, and so we look forward to connecting with you on your particular needs. And lastly, please make sure to join us for future digital discovery webinars. Next one actually quite related to this. We're talking a lot about CNC machine shops today from a data monitoring standpoint. Well, one of our next sessions coming up in 2 weeks, or rather the second week of August, second Thursday at 10:30, is with the organization called VersaBuilt Robotics, and they focus on CNC machine tending and similar solutions to really help manufacturers get started in that space. So even if you're already doing it, they actually have a unique checklist that they work with to help manufacturers get their foot in the door on that crawl, walk, run to CNC machine tending. So with that, I'd like to turn it over to Brendan. And I'll make you our presenter here, Brendan, so you can get started.
All right.
Okay, it should be in your hands now. Yep, we're seeing it.
All right, awesome. Thank you so much, Matt, and thank you again, everyone, for joining this morning. Just want to go through today, we're going to talk about data-powered production and how it can help you. We want to get into some of the best practices we've heard from our customer, how they're addressing today's increasingly competitive environment for contract manufacturers. So a little bit about Datanomix. Who's Datanomix? We help prescribe guidance on how to fix problems using machine monitoring, including solving problems with optimizing production performance and visibility. We have a best-in-class platform for machine monitoring. We also offer things like digital Gemba boards, and we have predictive tool life. Who do we serve? Who are our customers? Folks like you, job shops, OEMs. We also have long-term partnerships with people like Hexagon, Valin, and if anyone's using paperless parts on the quoting and estimating side, Karen Engineering and their Mac and MyConnect EBITDA growth systems. The EBITDA guys are fantastic. They're excellent at coming in and helping you turn around your shop, and a sales strategy, talk about ownership and succession planning. And ProShop is one of our ERP partners. We partner with all ERPs. So today we wanted to talk a little bit more about what drives revenue and what are the best practices to help us achieve more revenue. One of the big things people think about is, of course, machine uptime. Are we keeping stack lights green? Are we keeping machines running? And what are you doing to drive utilization today? What are you doing to meet that threshold you want to be at? Do we want to hit 2 million in revenue this year, 3 million, 4 million? What are we doing to help hit those goals? The old stopwatch, cycle to cycle profitability. Many of you have been out on the shop floor, tried to understand what is the overall capability of this process? What is a target cycle time I can hit? What should I promise to my customers? What should I plan for? And then where are we slipping? Where are we not hitting the cycle times we plan for? And what is the overall impact to my business on what that means? Labor and tooling costs. A lot of people we talk to today, they want to save. They want to save more. They want to save on tooling costs. They want to save on labor costs. What are you doing today to make more with what you have? Are you able to make decisions? Do we need that second shift? Do we need that additional piece of equipment? Should I sell that grinder? Do we really need that? Or is there a better way to optimize what we're doing with our spending, what we're doing with our assets and our labor? One of the best practices we see from our customers is just having additional visibility to understand what we're capable of doing. And then from there, we can understand how do we drive more? Where can we make more for less? Labor is always a challenge. How do we do more with the people and equipment we have today? The cost of a machining center is high. And what are we doing to get more out of it? And most customers we talk to, you're probably somewhere in this journey. Maybe your goal for this year is to maximize sales. Maybe your goal for this year is to better optimize key customers. Which are you chasing is a question to ask yourself as we go through some more slides here. Now, when we talk about visibility, yes, this is a black hole. No, we're not about to go into an astronomy lesson or talk about SpaceX, don't worry. Just want to understand more about what is the lack of visibility. And I've said that several times now. What does that mean? So when we think about what's happening on the shop floor, I mean, manufacturing is organized chaos on its best day. And just understanding where are the critical jobs, what's getting set up on what machine, when are jobs starting, when are they finished? Maybe you made 10 parts over the last 10 hours, but what actually happened during those 10 hours? It's hard to know. You see what happens at the beginning, an operator gets tagged to a job, someone logs into the ERP and clocks into a specific work order, and then you see what happens at the end once parts are finished, but it's hard to know what's happening throughout the day out on the shop floor. This is a very common thing we talk to people about, and I'm sure you've run into challenges of your own. I just want to know, why did we not meet that goal? Why did we not hit what we wanted to? So most people in this kind of environment, I need to get more information. I need to understand better what's happening out on the shop floor. People are trying to solve this problem, right? You probably have a whiteboard up in the shop somewhere. I'm sure you have Google Sheets or using something like Monday.com to try to understand where are jobs, what critical order is coming up next, and how do we address it? Tribal knowledge and gut feel, that's one of the biggest ones. How do you know what your planned time should be? Well, we've run this job, I've been here for 10 years, 20 years, I know how it should run, I've been doing this forever. But were you actually profitable the last time you ran it that way? Is that actually how it runs consistently time and again? ERP data is the other big one, just understanding manually tracking jobs, checking routed times, checking work orders. but still we're left with gaps. So in a best case scenario, we're trying to get more visibility. We're dialing into number 2 from the previous slide here. I'm trying to get some more visibility. I'm using my ERP data. So this is a very common situation most people find themselves in. And we're trying to understand, okay, what happened when this job ran across? Why was it different on first shift versus second shift? So you see, maybe these numbers were plugged in, at a workstation from the ERP itself. Maybe these orders were manually written down, handwritten. But either way, we're looking at the same job running on 2 shifts, and 1.5 times more parts are made on second shift. And why? We don't know. We just know the results, and we're trying to understand exactly what's driving this. How can we be better? How can we start to put in some best practices to level set and make production more consistent across shifts, across jobs? And it's just hard to do, right, with ERP data, with whiteboards. So we want to understand more about, okay, where can we see more visibility? So this is with Datanomix now. We have full insight into when shift started, what actually happened. So if we think about the example before, and we looked at shift 1, we made 24 parts, and on shift 2, we made 36 parts. And so again, this is the exact same scenario. So on the previous slide, we just had the chart out, right? We made 24 parts, operator logged in, it was shift 1, it was the same job. Shift 2, we saw 36 parts. Again, we don't understand why shift 2 was so much more productive than shift 1. Now, with actual visibility and insight into what's actually happening at the machine, we start to get some information. We can start to see that, late morning, we had some stoppage. We hit an alarm. What alarm is that? Why did that trip us up? During lunch, it looks like we walked away. We went to lunch early. Maybe someone else could have stepped in and just loaded that next part. Maybe someone had to walk away. Cycle times, how consistent were we? Looks like we ran tighter on second shift. Why is that? You can see, again, just inconsistent patterns of performance throughout the day. You'll even notice a score, right? There's a score of a B, and you can understand now that, we're off where that level should be, and we actually knew that during the shift. We knew that our production rates were not quite at our peak capability levels. And then when we look at second shift on the bottom, we can now see, well, wow, here's a much tighter running process. Here we have someone who's glued to this machine. He's been on task all day, making sure that the next part is getting loaded, making sure we're hitting the numbers that we need to. The other question that this brings up for anyone who's thought about labor efficiency and labor rates, a lot of people, when they think about what is the overall efficiency of my shop, I have a blanket assumption of 80% efficiency. Well, from a labor efficiency perspective, you might have had one person on this machine all morning on shift 1, and you would consider that 100% labor efficiency, right? He's at that machine, he hasn't gone anywhere, and he's doing that job as he's been asked to. But the actual efficiency of the machine, you can see the gap, right? So on top we have something more like 50-55% overall utilization. Towards the bottom we get closer to 60-65% utilization. So we're actually missing our labor efficiency standards and assumptions are off. What does that mean? What does that mean for getting things to our customers? What does that mean for delivery dates? What does that mean for scheduling and for planning? So these are all the things we can start to think about, the impact of not having this visibility, and what are some of the best practices to now understand, okay, we can run this job better, and let's have supervisors armed with better tools throughout the day to get jobs back on track. Okay, so we started with, I'll recap briefly here. So we started with talking about how do we get more? What are some of the ways to do that? We talked about visibility and some of the challenges. We're using whiteboards to try to understand where things are in the shop. We're looking at travelers and routers. And now we have this environment where we're looking at a wealth of information. Now we have insight into, brake performance and rates of part production. And okay, so that's great. So what? So what can we do now with this new visibility? So now we can start to understand, okay, which machines are down? Where are we seeing extended stoppages? Why are we seeing that? How long have these machines been down? We can start to see operators actually engaging and understanding, okay, why am I getting a B on this job today? Why did Steve on the horizontal mill, why is he getting an A-? And I might walk up to a TV and look at what the information is saying, and I might start to understand, okay, well, if I can dial in my work holding a little bit better, I can start to hit 5 minutes on this particular part where I have to flip it or reclamp it. And that's now something I'm going to look into. So what we start to see is now in this world of visibility, we can start to see operators taking on more accountability. They start to become mutually invested in the manufacturing process. How can I run this job better? We can now see supervisors can walk out on the floor and they can know which critical jobs are behind. Where do we need to get feet moving in the right direction of critical problems? Where do I need to put my best resources? Where is their time best spent? Then we get into questions of, we also talked earlier about making more revenue and being more profitable. So when we have this additional visibility now, we can start to understand, okay, where am I most consistent in jobs? Where can I consistently hit 40 minutes, 40 minutes, 40 minutes? Where are there jobs where we used to do that, but we're not anymore? And we're not sure why. Maybe there's a setup sheet that was lost, something happened. Where are those jobs and how can we get them back on track? Another key area, we call it losers with potential. Where are jobs that are actually slipping relative to what I quoted, what I promised the customer, but we've actually seen you perform well on that job before? Those are the areas we want to have high impact, right? We want to go after the low-hanging fruit of opportunity and efficiency improvement. And now we have data on realistic performance numbers for every job. Now we can have better informed scheduling, better informed planning. So part of the equation here is also change management and understanding how do we do more every day? How do we start to incorporate some of this visibility into our day-to-day workflows, how we run our weekly production meetings, how we do a morning toolbox talk. You make decisions now on the fly as you run the shop. You can understand, okay, that job is behind. I do need to get the right tool over to that work center. When we start to work with our customers, visibility, we go after key areas. So we might focus on an OEM might want to focus on cost savings. All I want to look at is reducing tooling costs and optimizing for the employees I do have. We might want to look at a long-running job. I just want a 10-year contract with the defense manufacturer, and I want to optimize my cycle times. I just bought a new palletized workstation to help run this job. Is it actually dialed in? Am I hitting the ROI targets that I set out for when I bought this capital equipment? We can see some notes from some of our customers here at the bottom, which is getting back to that idea of change management again. How are customers, what is the best practice? How do we actually use this data? So you can see Aaron Springer at Thomas Springer. He's using the data to help get ahead of customer production schedules. He's using it to better inform scheduling and sequencing of jobs. What should we run op 10 than op 20, or does it make more sense to leave op 20 set up on a different machine and we should actually run op 10 than op 30? Paramount machine, we can see programmers actually getting involved in understanding, okay, Datanomix cycle times look like they're slipping. Maybe there's a way we can rewrite this program, remove an air cut, and optimize the cutting paths differently. Uptime precision, using it in an even more different way. They're looking at operations planning. They're using this visibility to better understand capacity analysis, to better understand critical decisions. So now, in the world where we've achieved insight into what's happening at the machine, we can start to get answers to some of these questions. So in all the time spent, collating manual routings, manual work orders, time spent up at the whiteboard, we can now start to actually answer some of these questions. We can understand, where are we slipping? What's an actual good goal? So we can start to introduce KPIs and metrics. I want to start tracking some of our customers. A best practice might be week after week, I just want to track towards my overall uptime hours. Am I hitting it? That might be one area to start. Another best practice might be to say, okay, well, my utilization goal for my hand-loaded lathe is more like 35%. I know the guy who runs the hand-loaded lathe, he's typically tending to some other machines. I want to hold him accountable to 35% for that piece of equipment. Now, on my 5-axis, that's a critical piece, and I want to keep that running. I want that more at 65, 70% utilization, and that's a goal that I'm going to start to now march towards across the shop floor. Profitability. Again, where do we need to re-quote things? Where are we losing money? Where do we need to understand what the actual runtime should be? Savings, what's my OEE? Am I really getting the most out of the people and equipment I have today? Where are the bottlenecks? Whack-a-mole. I might fix a process in one area and then it moves. Now I'm hung up in a different part of the shop. Tool life, what is my expected tool life? Are we actually hitting the cycles we think we are? Are people changing tools too early because they're concerned that it might break or break a spindle when actually that tool had about 50 more lives in it? And what's the cost of that over time? Where should you start? So we typically, one of our recommendations, one of our prescriptions is to start simple. So I think Matt mentioned at the outset of the call, crawl, walk, run approach. We also believe in a crawl, walk, run approach to machine monitoring and starting to use this data. So what we call it is quick wins. It's just the low-hanging fruit. We've observed across 150 plus contract manufacturing shops and OEMs, we've observed that the biggest opportunities for time back and efficiency improvement in the shop are in simple things. Things like understanding, when are machines getting up and into cycle at the beginning of the shift? Where are people powering down from their workstations towards the end of the shift? What is the actual cost of that behavior in those processes? Stop machines. Let's not focus first on shaving seconds off of every part on every machine. First, when we come in and work with a shop who might be new to data, new to machine monitoring, we might just look at, what are the biggest culprits? Where are the extended stoppages, and how much time is that really costing us? And then having active workflows to help you act on that in a simple, easy way, just with your phone buzzing. Having your phone buzz when after 90 minutes, the machine's still down, supervisor can now walk over, hey, what's going on? How can I help? And the last bucket here is time on tap. We call that time on tap. Again, it's what I mentioned at the beginning. It's just those areas of time towards the beginning of the shift and towards the end of the shift. So Datanomix, where does this all come together? You're probably wondering, how do we actually do this? How do we get all this information from the machines, from the jobs? We connect to the machine. We look at all the lines of G code as they're executing. We can see the active program, the active file name of the program that's on the machine. We can see, are we sitting at an MO, an MO1, an MO? What is the exact reason for the stoppage? Can we figure this out automatically? We've seen first generation monitoring systems typically will prescribe a tablet at the machine, and all of a sudden you have operators and machinists manually tagging every single downtime event. Well, we've actually found that 80% of all downtime is expected downtime. It's written into your programs. It's where you have to clear chips. It's where you have to flip apart. It's where you have to reclamp something, retorque something. We've used the G code to help understand that and to automatically inform, so your highest, most precious assets, your people, are not manually categorizing and logging data all day. The second part, again, going back to change management, is we're here to help you with that. You know, we do this all day, every day, just understanding what is an easy workflow in a chaotic manufacturing environment that my supervisor can actually use to make some positive improvements, and understanding that every manufacturing environment is different. And in a high mix, low vol shop, we might go after setup and changeover opportunities. And in a different type of, you know, higher volume type shop, we might really just be lasering in on cycle time. So it's every shop is unique, and having a partner, a team that can help you go through this change management piece is increasingly important. Yep, so again, we covered this, you know, just talking about stop machines, what's down, what does that actually look like? It's a TV out on the shop floor. It's immediate level set of everything that's happening. So supervisor can walk by, director of operations can walk by, ownership can walk by and look up at the TV and understand that, yes, we care about this. This is important to our culture. This is important to what we're doing. Notifications, again, just coming from the phone. Time on tap, that's just a snippet of one of our easy reports and workflows. And then ROI is you're typically talking about an additional hour of uptime per machine per day. That's the overall impact that we see across our customers. And now just real quick, we're running up on time here. Phoenix Meccano, one of our customers wanted to do a quick case study, and Phoenix Meccano, one of the biggest benefits they saw from working with us, just real quick, they are a manufacturer of components for automation technology, aluminum extruded parts, watertight enclosures. They do machining, they do surface treatment, branding, assembly, and integration. And Phoenix Meccano, we partnered with them, we helped connect their machines. And one of the biggest things that they took away from this was actually cultural. They discovered that the operators all of a sudden began to understand what is the overall vision of what we're doing at Phoenix Meccano and how can we become a part of that. So they saw at morning meetings, people looking at the data from yesterday and using that to better inform changes as they've happened. You know, the director of operations over there, he could barely remember what he had for breakfast, but having the data available in a report he can easily reference back to all day massively helped him improve operations out on the floor. The real-time feedback piece was huge. They saw operators understanding, how can I run this part better? Why did Steve get a B+ when I'm only getting a B? They turned it into a game. They saw competition, and they tended to remember when jobs came back, hey, last time I ran this job, I remember getting an A-. I remember getting a B+. This time when I run it, I'm going to do even better. So you start to build that understanding of process capability, benchmarking, and that starts to become ingrained in everyone out on the shop floor. We also did an ERP integration, digging further into cost analysis and feedback on individual parts. And the overall impact is what we see on the right here, 40% improvement overall in parts produced. And that's, you know, coming together through a number of factors of, you know, implementing a plan, a dedicated project plan, starting with some easy workflows, some of those quick wins we talked about earlier, and then ultimately ingraining it in the overall culture of the shop. So Matt, I think I'm at time here, and I'll wrap it up for any questions.
Well, excellent. Thank you so much, Brendan. It was great information. I mentioned it in the chat, but definitely anyone online, if you've got some questions, please post them into the questions panel or the chat window that you see on the sidebar there. So as people are, you know, thinking that over, if they do have any, one that's come in already, you know, you mentioned a little bit about ROI. How do you approach estimating that for a shop if they're going to consider Datanomix? You know, what are those key factors or considerations that you focus on to generate that potential impact for the investment they would make in the system? And I guess as a follow-on question, have you ever met a shop that isn't a good fit or that wouldn't benefit?
Yeah, great Great questions. So first question, number one, ROI. A way to think about ROI with starting to introduce data-driven decision-making in the shop is how much time is this going to save us? How much time back are we going to get every day? So I mentioned before about some of the workflows of just having notifications that buzz when machines have been down for more than 90 minutes or whatever it's based off of. That and having a TV out on the floor just broadcasting performance and just creating that accountability and visibility. And then combined with looking at some reports of where are we losing time across the shift, those three things alone, we typically see about an hour back per machine per day, just doing those three things. Now, different shops are in different evolutions of their own journey in contract manufacturing, and some shops may run differently than others, but that's typically for someone who's new to data-driven decision making. That's typically what we see. So an hour back per day, now you just apply that to your shop rate. What is your shop rate? What is the balance of that time? What is the new revenue generating opportunity of having that hour back per day on that machine? And it's the dollars add up. So that's number one on ROI. Number two, remind me again, Matt, what number two was?
Oh, like if there's ever, what would make a shop maybe not looking at the other way, who wouldn't be a good fit? Or are there any shops that maybe wouldn't be a good fit for one reason or another?
Yeah, so shops that aren't a good fit, really prototype driven shops. So if you see your work changing every day on every asset, it's harder to use the data to come up with some of these conclusions and to help drive decision making. Now, there are still environments like that where it does make sense, where they do want to understand what are my total machine hours, what are my total production hours. So we do sometimes see that. Yeah, I mean, there's a place for data in every manufacturing environment we come across, and then it's just a matter of what problems are you trying to solve? Are you trying to get better? Are you trying to improve? I mean, sometimes this doesn't work if you have a massive sales problem and you need to get more work in, more business in, then this probably isn't the time to start optimizing operations and going after efficiencies. This might be a time to boost overall sales. So it's dependent on kind of the overall top-down environment of the shop.
Okay. And another one that we have come in, how do you work with customers who have increased data security requirements, such as ITAR environments?
Yep, great question. So we are fully NIST, ITAR, CMMC compliant. And the way we achieve that, so our ITAR certification, what we do is we're read-only from the controllers. So we're never going to tell the machine to do anything. We have an on-premise device that we typically set up a segregated network for your machines to be separate from all of your other business systems. And that allows us to read only from the machine what's happening in the G code. And then that G code never leaves your facility. And the only thing that punches out, so we do our UI is cloud-based. It's in the Microsoft Azure cloud. We use US data centers only. And that allows us to achieve that ITAR certification, and your G code never leaves your facility. The only thing that's in the cloud is what we were looking at before on the visibility slide with, okay, here's what we can see, here's how many parts we've made, this machine stopped. So it's never anything actually proprietary from the shop.
Okay, excellent, excellent. And another we have, talk about the implementation on this. Is this akin to implementing an ERP, or share a little about that?
No, so this is not at all like implementing an ERP. It's fast, it's easy. There's no downtime from your equipment. So we typically will send an engineer. They might just look at some setting screens on your controller, look at IP addresses, open up a port, and then it just starts kicking off data you can still be making your parts as that happens. So there's no downtime. There's no big overall interruption of business systems. We're really just tapping into the actual machine itself and starting to extract some of that meaningful information. So we're typically up and running in less than 2 weeks. It's really just a couple conversations with your IT manager. We look at some sample programs and we schedule the installation.
Okay, perfect. Thanks for that. And I think we have one more here. So in this scenario, they've got pretty experienced operators. They've been around, and machinists that have been there for a long time, and they've looked at some monitoring solutions in the past, or maybe trialed some things, and they didn't really like that big brother feeling that they got, and it wasn't very well accepted. How have you seen companies get over that, or is there some particular benefits that really help the machinists that might help reduce their hesitation in those scenarios?
Yeah, no, that's a big topic, and the idea of big brother, you want to roll this out to the shop correctly. So this is also where having a dedicated partner who's here to help you is really important. So we actually will set up a unique shop floor communication plan for each of our customers. So you might be an ESOP, an employee-owned organization, or maybe it's family-owned. But either way, we want to contribute in the right tone what we're doing. This isn't a punishment tool. This is about understanding production, understanding opportunities, and improving the overall business for everyone. So that's a key part of it. Also, we found that most people, they find it interesting. Once the TVs go up, there's a lot of anticipation around it. And once the TVs go up, it's really just stop machines. It's, hey, how did you know? That's crazy. You can actually see what the MO was I was at. So we typically see people start to become engaged, and they start to ask questions. And it's that process of asking questions about what's on the screen that can actually help employees now have more of a stake in the overall success of that part of that product.
Okay, well, no, I appreciate that, and that makes a lot of sense. So again, we'd like to thank you, Brendan, for joining us today. I think it was a great session, and certainly if anyone on the line has any further questions there, you can reach out to myself or others, and we'll make sure to get you in touch with Datanomix and explore how this might be able to benefit you. So with that, I'd like to thank everyone, and thanks again for your time, Brendan.
Thank you, Matt. Thank you, everyone, for joining, and have a great rest of your day.
Yep. Have a good one, everyone. And remember, you can watch a recording or share this with your colleagues who may not have been able to join. You'll see the recording link be shared here in the coming days once everything's uploaded and ready. So thanks again for joining, and have a great day.